The day after Labor Day, it's September 8th, 2020, and I'm doing the number activity walk right now with you, but I wanted to actually do it here in my living room because I saw something yesterday that I wanted to show why it is that I developed NumberLinx and got a patent on my NumberLinx process. And I had them here in my living room as we just got delivery of some more of the puzzle pieces. I saw something yesterday from ABC Mouse where they had all of these things, and I tweeted it out, where they have levels 1 through 10, and the numbers are sitting in shapes. And a child and parents have asked me, what do those shapes have to do with those numbers? And I said they don't. In fact, they add confusion, because I get asked by students and parents and teachers, and they sort of ignore them because, well, maybe they didn't mean to have any relationship. Well, if they're not meant to have a relationship, then don't add confusion, is what I would say as a teacher. But it's also why I developed my NumberLinx, where I do make the shapes and the numbers link together. And we're going to make an alternative page and tweet that out later today. My NumberLinx, you see, has a 0. It's in color of a color wheel to give a reference also to artists. It was given a design award actually and won a trophy as the best invention of 2016 and during 2017 at an international invention fair. Amazing that an educational thing would ever win a trophy. Anyway, that 0 becomes the center because 0 is the center of our number line. He's the center of our Team 10. And physically you see it and you hold it and there's no knobs. Okay? Now, the relationship here is each is a shape with the number of points. And we actually have engraved a little teardrop or a star. They're called pentagrams. Stars are pentagrams with as many points. So 1 is sitting in a 1-pointed shape. It's a teardrop, and there's a 1-pointed pentagram, a 1-pointed gram, a unigram for the little one here. 2 is in a heart with 2 points, and we have two pointed stars. And 3 is in a triangle. I use the equilateral shapes here, and then we get into more complicated shapes. So 3 with 3 pointed, and 4 with 4 pointed stars, 5 and 5 pointed stars. 6 is in with 6 pointed stars in a hexagon, where they had 9 in a hexagon. What does 9 have to do with a hexagon? Nothing, all right? So I don't understand that at all, and that's what children ask me. 7 is now in a septagon or heptagon with 7 pointed stars. 8 in an octagon with 8 pointed stars. 9 in a 9-pointed polygon, 9-sided polygon, nonogon with 9 pointed stars. And the numbers fit inside. So you actually kinesthetically put the puzzle together. And if you put it together upside down, then you have to learn how to get the color in there. And you have to realize you have to flip it. So this has won incredible awards, but it goes to the lack of confusion and the linkage of shapes and numbers together. And that's why I developed this, because I saw too many places in classrooms where posters didn't put them together, and otherwise if they did, they made confusing relationships which aren't necessary. If you're trying to teach, you want to reduce confusion so that the people understand what is going on. And when students have asked me about these things, and parents, and they say, well, we don't know, we just, maybe they just put it like that to do it that way. I say it adds confusion, and you can say, how would you rearrange them then so that they made more sense? Okay, so now my next level of pieces even takes this concept another level, where you learn more about shapes for the future, not just shapes for the past. Non-standard shapes are becoming more and more important as we learn about things in 3 dimensions and NASA and up in space and dealing with high-level digital databases. So in preparing students for the future, not the past, as much of our education is, then we need to look at what we might need for the future. And one of the things that actually made this become a patent is that I worked on the Pentagon, and I had to deal with the U.S. Patent Office to actually show them that these two pieces are pentagons. It was the pentagon that really got the change. People have made four-sided objects out of four-sided objects, but never pentagon out of pentagon. So this is a pentagon because it has 5 sides, and we don't show students shapes that go inward, and yet in architecture and design these are very important. And you could design a garden with maybe 5 different plants in this pentagon. That's where I want this depth of knowledge of numbers to be. So in this pentagon you see these two, I call them kissing pentagons. This one's also a pentagon with a 5-pointed star, or a pentagram, and that's the most famous one, but actually it is a polygon of 10 sides, but we see the points because it's a star. You put these together, they form a pentagon equilateral. So 5 points or 5 sides put together with 5 points or 5 sides creates a 5-pointed or 5-side polygon. Again, when you work in geometry, you're not working linearly. So these will fit in the pentagon in there. And now we have 2 pieces. We have a star and a number 5. And these are very good for looking at developmental in addition because it has the flipping. So you can see if someone can figure out what has to happen to be able to get the pieces in there. So we have a star and we have a number 5. The star can fit in with the color up or the color down, and because you will learn about the symmetry that the star can be symmetric with respect to the point, so it can be up or down. Where the 5, oops, if I want to get the 5 faced up, you say, well, I'll turn this over, but if I turn this over, it's not going to fit. So you're going to have to turn both pieces over to flip to put it together. And that learning about flipping and seeing in 3 dimensions is a very big developmental step. But here again, you can put the star face up with the color, or you could decide to be cool and it fits also face down because the symmetry of the star is different than the symmetry of the 5. So there's a lot of learning in here. This is why I developed NumberLinx. It even goes further and further and has cards. For example, these are domino cards that fit in here, can be played as a game. There are 70 different cards. Some of them are blank. Some of them have animal series. But it is to link patterns together with numbers and to show how numbers are define what we live in the world through design, pattern, and shape. That's why numeric systems were developed, was to describe what we saw in the world. This is the numbers lady. This is September 8th, and I wanted to show you how I responded to something where I got an immediate question yesterday, and I wanted to show what was sitting in my living room that actually is the response. There will be a Twitter response and a photographic Instagram response about both of these today as we get the artwork done to put that together in the same framework. We want to look for things that are not confusing, unless you want them to say, what is it about it that doesn't make sense to you, or how would you redefine it? You can use those things for learning, but if you're starting out when they're young, the issue is to layer what it is that they're learning so it's consistent and you see the patterns that they will see in the world. This is the Numbers Lady. Goodbye. NumbersAlive.org.